Hello everyone. We're very excited to have you here for our webinar today on Docker, DevOps, and Cloud Storage on AWS. Our speaker today will be Joey Wright, a Solutions Architect here at SoftNAS. And before we begin the webinar, we just want to cover a few housekeeping items. Number one is that you can listen to this webinar by either dialing in through your phone or by using the mic and speakers on your computer. Second, we will be answering questions at the end of the demo, so at any time while we're speaking, please feel free to type in your questions in the questions pane here on GoToWebinar. And finally, this webinar is also being recorded, so you can view it on demand. After this webinar, we'll send you an email with the link and with links to the YouTube video and the slides on SlideShare. Also, we want to announce that we are giving away 100 AWS credits. At the end of the webinar, we're going to give you a link that allows you to register for a $100 AWS credit, which is completely free. And then the agenda for today's webinar is we're going to talk a bit about Docker, DevOps, and cloud storage and how it applies to AWS. We're also going to demo how to build Docker persistent storage on AWS. And then after the demo is done, we'll talk a bit about some of the Docker storage challenges that a lot of our customers see on a daily basis. And then we'll also talk a bit about SoftNAS Cloud to give you an overview of how the product works and answer any questions you might have around that. And then finally, we'll discuss some next steps around trying out SoftNAS and checking out a couple of our white papers. And finally, we'll have a Q&A to answer any of the questions that you might be asking during the webinar. And with that, I'm going to go ahead and hand it over to Joey to do the presentation. It's all you, Joey.
Thanks. Let me go ahead and share my screen out for you guys, and we'll go ahead and get this started. All right, so to go ahead and kick this off, again, my name is Joe Wright. I'm a Solutions Architect with SoftNAS. So we're going to be just talking a little bit about how our solution can impact and help you guys when you're dealing with Docker and DevOps and or any particular cloud storage challenges you might be facing. So hopefully everybody can see my screen. If you can't, let me know via chat, and I'll definitely stop and back up, and again, just ask questions as we go along. So as it relates to Docker and DevOps, these are definitely two words everybody knows. I think my 10-year-old even knows these two words. They're so popular now within the industry. And if you're not familiar with them, chances are you're probably out there researching them and thinking about whether or not they can assist you within your organization to make your delivery of your applications much more streamlined and effective. And we've just got a little bit of a survey reflected here, just illustrating pretty much what I just said, that currently if you're not in the process of actually doing DevOps, you're probably in the process of researching DevOps and how it can impact you either at an organizational level or a business unit level, etc. So we only expect this to become more and more popular as time progresses, because it's the natural order of things. We definitely want to become an application-centric environment, and we want those applications and the life cycle of those applications to be controlled as efficiently as possible and have every component of IT working together as efficiently as possible. And what we're doing is we're extending what we can do as a storage company to both DevOps and Docker. And if we start looking at container storage options as it relates to Docker specifically, you can currently spin up a Docker image or a container, and you can throw your application in there. That application might be something as simple as Apache to spin up. And storage is most likely temporary. It's ephemeral, meaning once that container is gone, that storage is gone. And we're more than likely configuring this on our host. whether we're spinning this up in a VM for dev, whether we're spinning this up on something a little more enterprise-centric, or Hyper-V infrastructure or vCloud infrastructure, or maybe we were already doing it in the cloud. Chances are we're still using host-level storage, and we're sharing these containers on the same host, and we're configuring security and the parameters for each one of those containers on the same host, and we're dealing with all the challenges that are associated with that. We can also leverage network storage. So this is where we start getting into creating just mappings, exports, NFS exports somewhere else, iSCSI block runs that we can attach to machines, basically just offloading storage requirements somewhere else. There are definitely some benefits of that. We start getting into some manageability aspects, some scale aspects that definitely make network storage something that's much more palatable towards the enterprise, much more tenable as far as management and DevOps are concerned. But then we start looking at some additional options. Well, now we have cloud. We bring cloud into the mix. We've got this proliferation of all these different block devices depending upon what your cloud provider is, Amazon, AWS, Microsoft Azure, whatever it might be. We've got a lot of different offerings as it relates to our block storage. As it relates to object storage, we've got several different flavors of object storage that we can now bring to bear and start leveraging within DevOps, within our Docker containers. Again, based upon your cloud provider du jour. And these are good because, obviously we're going to start leveraging the infrastructure of someone else that's in the data center, that's in the business of making things highly available for us, and that can only be a good thing for us as developers, as people that want to get applications out to our community or consumers as fast as possible. There are definitely some challenges, though. We are limited by the speed of light, and sometimes when your storage is at the opposite end of the globe from your application, there could be some issues that we need to take into consideration. And as we continue on with this container storage option, we can talk specifically about AWS ECS, the EC2 container service, whereby we can instantly provision objects as we need them, Docker images included if we want to get fancy and start using some scripting here. And we can make them redundant across geographies, across availability zones, however we see fit. So we've got a lot of storage options now that are out there that we can integrate into our DevOps platform that we can leverage specifically with Docker. And what we're trying to do is we're trying to determine why you should even care about this. And we think it's very important that when you start developing these processes, when you start creating these containers and you start deploying these containers, that you have the ability to configure these environments one time and run anything you want, specifically wherever you want, and maintain the consistency and the efficiency and the repeatability that DevOps brings to the table, but most importantly, be able to maintain the data that we don't necessarily want to be ephemeral if we're talking about Docker. We want to be able to control security. Docker brings some challenges that we need to take into consideration with regards to locking the environment down, locking the underlying storage down so someone doesn't get outside of that container and start taking control of objects they're not necessarily supposed to. So we need to start taking all of those existing considerations and now applying them to our different cloud storage options and seeing how we can make life better for everyone involved. And what we're looking to do specifically with SoftNAS is we're looking to bring persistent shared storage to this paradigm. So this means what we're going to do is we're going to stand up SoftNAS, and we're going to abstract our Docker containers from the type of storage that's actually powering or back-ending all of our data, meaning we don't care if it's block storage, we don't care if it's object storage, technically we don't care whether it's Amazon or on-prem in your VM, etc. We simply want to give our containers and our storage a mechanism by which they can spin up an environment, very quickly access the data they need at the performance they need, and most importantly, when that container ceases to exist, have access to appropriate information that's now persistent, no longer disappearing when the container disappears, etc. So, and we do that by leveraging SoftNAS. And before we get on and actually start demonstrating a little bit about how SoftNAS is going to facilitate this or allow this, we do have a poll. So I'm going to go ahead and hand this poll back to Taryn, and we'll see what answers we can get here.
Thanks, Joey. All right, so we're going to go ahead and just launch a quick poll to learn about how your company is adopting DevOps. So I'm just going to go ahead and give this about 30 seconds for y'all to answer. But basically, our answer choices are, is your company adopting DevOps company-wide, or are only specific departments using it? Is it more on a project or team basis? Or is it more along the lines of you guys just, aren't adopting DevOps and you're sticking with the status quo? Or are you just, not sure? So I'll just go ahead and give that a few more seconds. About to close it in about 5 seconds. All right, so let's go ahead and look at the results. And it looks like we've got a pretty even split of DevOps adoption across companies. About a quarter of you are using it company-wide, which is fantastic, and about a third of you are using it on a project or team basis, which I think is great. And with that, I'm going to go ahead and hand it over back to Joey so we can move on to the demo of Docker storage on SoftNAS. It's all you, Joey.
Great, thanks. So I'd definitely be interested in talking to some of you guys, in the future of how you're leveraging Docker and if you are having any kind of storage challenges, etc. Conversation for another time, but what we want to do here is we want to let you know some of the benefits that AWS and SoftNAS bring to the table. And so what I'm going to specifically do here is I'm just going to show you a little bit about SoftNAS and how we're going to provide persistent shared storage to your Docker containers. And on the right side of the screen, I do have for sharing a white paper that we currently have published and available online. We'll make sure everyone has access to this white paper that simply walks you through how to use or leverage your containers with SoftNAS persistent storage. So having said that, what I'm going to do is I'm going to go ahead and I'm going to log into a SoftNAS system that's currently installed inside of AWS. So it's going to yell at me because I haven't updated a certificate here. But once I get into this, what I've done here is I've built a SoftNAS system inside of AWS using a community AMI, a community AMI. And this is called SoftNAS BYOL. And after you install this system and you go through the initial setup of building that AMI, sizing your instance, etc., this is the interface that you're going to be greeted with. And inside this interface, what we want to do is we want to configure some storage that we can leverage via Docker. And we do that quite simply by going into a disk devices applet. And it's from within this applet that we start this abstraction process. Meaning our end goal here is to have Docker no more concerned with the fact that it's accessing EBS block volume data or S3 object data. We don't want Docker to concern itself about what region it's coming from, which availability zone, etc. We simply want Docker to be able to very easily mount the storage that we're managing for them. And to that end, we also want to be able to create this storage layer in a very easy and efficient fashion, something that we can integrate within DevOps. And to that end, we do have a CLI and an at-rest API to automate everything I'm getting ready to show you. And our goal here throughout this conversation is to hopefully illustrate that we're going to remove all the heavy lifting or the burden of the heavy lifting from the person sitting down at this console. We want you to understand the business case and the driver, the reason for you to need this storage, and we want you to very quickly and easily step through the process to create or satisfy those requirements so you can get to doing what's important, and that's creating and deploying those applications. So as it begins, we're going to go through an add device process. And this is where we choose whether or not we're adding a cloud disk extender, i.e. object storage, or a block level disk, an Amazon EBS disk. And for this exercise, we can very easily add both. So I'll just start with our elastic block stores. Now here, what's going to happen is we're using roles within AWS, something that we as a community leverage very heavily. So we're definitely extending that paradigm. I do need to determine my disk size here, and I've decided that I don't need much space for this particular exercise, so I'm going to create a couple 5 gig disks. We do offer the ability to pass through any encryption that's offered by your cloud provider, so that disk encryption that's provided by Amazon EBS, we can light up here. We even have the ability to provide our own encryption at the file level, which we'll discuss in a minute. We then have the option to choose from the different types of EBS disk offerings that we have out there, from general purpose all the way down to standard magnetic. And I'll leave this as SSDs. I'd like some performance, but I don't necessarily need the added fiscal requirements of provision IOPS at this time. So the next thing I'm going to do is I'm going to determine how many of these disks I need. Well, my ultimate goal was to take these 3 5 gig disks and actually stripe them so I can combine the IOPS of all 3 of these disks and kind of get some more bang for my buck. Now there are some rules that I'm kind of skirting here, meaning Amazon does provide a certain level or a certain amount of IOPS per size of the volume. So we'll just ignore that and assume that I'm getting great performance by striping across all these volumes when it gets to that point. So we've got some block storage here that's now getting ready to be assigned, and while we're waiting for that, I'm going to go ahead, I'm going to add some object store here. So I'd like to connect to my AWS S3. So what we're going to do here is, again, we're going to leverage a role that's sitting in the background to make sure someone actually has the ability to consume object storage. I'm going to choose the region from which I'd like to pull this bucket. I am configured in Northern California at this point, so I'll just make sure I'm pulling from Northern California. We'll assign a bucket name. This can be anything you want. It can even be specific to your Docker exercise here, if you like. And then we're going to select the maximum size for that bucket. Now buckets normally kind of dynamically grow in the background, but since we're turning these into something that we effectively manage as a virtual disk device, we're going to set the maximum amount of data that can be written to that bucket. Doesn't mean we're arbitrarily just grabbing that amount of information. It just means we're only going to allow whatever's attached to this disk to only write that much information to or through that bucket. So I'm going to go ahead and make this a 10 gigabyte bucket. And we do have the ability to make that gigabytes, terabytes. And we can scale up to 4 petabytes within any single object storage limit. We do again have the option to pass through any encryption that the provider might be using. So in this case, Amazon does offer encryption for their object store. We'll just use that. So what we've done is we've simply attached storage as provided by AWS to the SoftNAS system. Now what we're going to do is we're going to aggregate all of these storage devices, or virtual storage devices in this case, to what's called a storage pool. And the storage pool is how SoftNAS is going to manage the aggregate data. So it's from the storage pool that will ultimately build the access points that Docker can leverage to create persistent storage. As these storage pools are concerned, we're going to go through a wizard called a create wizard again. Hopefully it's going to look very similar to something we've used already. We try to maintain continuity there and make things relatively easy for people that are sitting down here. Now as far as pool names concerned, I'm going to keep this relatively generic so everybody can follow along. So I'm going to create a pool of those 3 5 gig disks, and I'm going to call it EBS data. And since we already have an incredible level of redundancy provided by Amazon, the only thing I'd like to do is to get some additional performance by implementing a software RAID 0 for striping. So there is some overhead associated with this because it is software RAID, but that's okay because the IOPS that we're going to get are going to more than account for the couple hundred megabytes of storage requirements that that software level RAID is going to require. So I simply select my disk from the available disk shown here, and you can see we do separate our devices by S3, object storage, or Zen virtual devices, the block level storage that Amazon provides us. And then we have the option to, if this is a block level pool, to leverage file system encryption. So if you have that need for your particular application to provide at-rest encryption at the file level, at the disk level, or even in flight, we have the ability to do that. So I'm going to go ahead and enter a password here for that Lux encryption, AES 256, and I'm going to go ahead and create this pool. Now it does take a couple seconds for this pool to create. But once this pool is created, we're going to take a certain amount of that storage pool availability. We're going to reserve that for the file system we're going to put on top of this. We're also going to reserve some of that space for that RAID 0 stripe I put into it. And ultimately, of the 15 gigs, we're going to have 13.4 gigabytes available for our container or containers that we actually mount to this pool later on. So the next thing I can do is I can go ahead and I can create object data pool. So I'll just call this S3 data. And here, since we're not using block devices, we're not going to get much performance benefit by striping. So I'm going to choose no RAID and simply choose my big monolithic 10 gig drive here. Now, I'm going to go ahead and create this so we have two pools to choose from. Now, what's interesting while we're in this configuration for these storage pools, should your application require performance that's above and beyond the characteristics of the disk associated with these pools. For example, maybe we're using magnetic disk for EBS, or we're using S3 object data on the back end, or object store on the back end. In order to increase performance, we do have the ability to leverage high-speed SSDs for both read caching and write logging. So for all that data that's most frequently written or most recently written, we can maintain a copy and maybe those ephemeral SSDs that are associated with your instance within Amazon or on a preferred IOPS drive. Now all of a sudden, even though we're front-ending object storage, which isn't the most performant of backends, in fact it's throttled at certain levels, we can make reads function at a very fast level. And the same thing applies with writes. You know, we can leverage preferred IOP drives or local persistent SSDs. No ephemeral storage in this case, but we can extend the amount of information that we effectively have in flight by augmenting RAM with high-speed SSDs. Again, increasing the performance characteristics of whatever it is we're front-ending, be it block storage or object storage. The only caveat being those devices need to be faster than whatever we're front-ending. So now that we have these two pools, in order to make them available to our DevOps community in general, or our applications, our Docker containers, we're going to build volumes and LUNs. And this is where we actually build our NFS exports, so we can simply start creating these Docker containers and mounting those Docker containers via the exports that we're going to build. So the way this will essentially look is I'm going to build a share here, or a volume, excuse me, and that volume name can be something as simple as SoftNAS. It can be, you know, whatever your naming requirements are, etc. So I'm going to call this SoftNAS. I'm going to assign it to a storage pool. It doesn't matter which storage pool. In fact, we can have multiple volumes pointing to the same pool if we like. So I'm just going to choose Object Store here to begin with. So I now have a volume called SoftNAS pointing to that object storage data pool. Within this data pool, we're by default going to build an NFS export. We could, in fact, create a CIFS and AFP, an Apple Filing Protocol, mount to that same exact volume. So now you have three different protocols that could connect to and consume data from that one same location should your use case require that. So in this case, though, we're really only concerned about creating those exports. So we can go over here, and after we make that mount, we can go ahead and actually connect our Docker to the SoftNAS share that we're ultimately going to have created. So once we choose the volume type, NFS, CIFS, AFP, or even an iSCSI block device, we can choose how we're provisioning. We can thin or thick provision these things. So if you theoretically are creating a single volume for each container, we could go ahead and we could allocate the amount of space in megabytes, gigabytes, or terabytes for each one of those containers that are going to be connecting to and consuming this data. So if you have a multi-gigabyte pool, we can prevent this particular volume from ever consuming more than 1 gigabyte. If that's not an issue, obviously, we're going to allow things to organically grow until we consume that space that is available, 8.9 gigs in this case. So our last option supports inline compression and deduplication. So should the type of data that you're creating or managing allow us to compress or dedupe, we do offer those options just to save space on the back end. Now, another interesting thing that's not commonly or routinely made available when we start dealing with Docker is the ability to create snapshots based on the data that we're actually building this container on. So we have the ability natively and per volume to define a schedule by which we can create snapshots. So obviously the first snapshot is your base data. Every hour thereafter we have the ability to define a schedule that's going to create deltas for us. So once we define these schedules however we see fit, maximum being every hour on the hour, we can actually, of those snapshots, define a retention policy. Once we have that policy in place and we create this volume, we will have the ability, once that policy is executed, meaning we've waited at least 1 hour and we have a snapshot, to go back to a prior snapshot at a prior point in time and mount it as an individual volume. So the example is here. I just built this SoftNAS volume. We're mounting to an NFS export called SoftNAS, and I'll show you that in just a second. If I go down here to the Snapshots tab, I don't have anything in this list because I haven't met that policy we just created. But if I were to force this creation of a snapshot and or this container's been operating for a period of time, you would see a list that is sorted by date and time. So should you need to go back to any point that's available within this list, i.e. based on that retention policy, we simply select that point in time and we can create a snap clone. Now what's important about this is we are creating a readable, writable volume based on the parent type. So we've got a new volume called SoftNAS already mounted as an NFS export that contains that data from that point in time. So now if you need for test, dev, QA purposes, whatever the reason might be, to access that data or act upon that data at that point in time, we've stood up that snap clone just that fast. If you actually need a persistent copy of that data, meaning one that's not linked to its parent, as it is right now, we do have the ability to promote that clone to an independent status, so you could actually start building upon or developing upon that copy of that data based upon that point in time. So just that quick and just that fast, we can give our teams access to data at a point in time based upon that policy we define. So that's something that is very frequently leveraged and is very powerful depending upon how we integrate that into your DevOps processes. So for those people also that might have to deal with Active Directory, or if you're using this for use cases outside of Docker, we do support integration within Active Directory, etc. Now, if I move over here to our NFS Exports tab, real fast you can see that we have and automatically build our root export. You can actually see some exports I left in here and forgot to delete from my demo system, but most importantly, you should see the SoftNAS setup that we just built. So here you can see S3 data, SoftNAS, and here you can see S3 data, SoftNAS clone. So we've gone ahead, we've created the export for both of those locations, and now you're free to go out, mount those locations on whatever machine you're using to create your Docker instance, and actually go ahead and spin up your Docker container leveraging that export, assuming your export's called SoftNAS in the example on the right. Now, Extending upon this scenario, you even have the ability to replicate this data somewhere else should you need to. Maybe you're doing a lot of your development on premises, you're maintaining this data set on premises, but should the time come to go ahead and push this out to the cloud, perhaps you're maintaining an automatic replication cycle in the background that tells SoftNAS to automatically replicate this information to a cloud server somewhere. So maybe we're going from on-premises to cloud. Once you're ready to go in production, we just assume primary production role for storage in the cloud on the SoftNAS device, and now all your containers mount to and consume all that data that's already been made persistent on premises. Or perhaps we're doing this from a DR perspective or a business continuity perspective, whereby we want to maintain replication across geographies, etc., even across cloud providers if we choose. So replication is very powerful. Now, should your replication cycle maintain a pairing where the two machines are in the same network, we even have the ability to introduce what we call snap HA or high availability into this mix. So in this scenario where my SoftNAS server that you're looking at is built into the Northern California region and availability zone 1A, I could build another SoftNAS instance in 1B, replicate between the two of them, and then should a HA controller determine that zone 1A is not available for whatever reason, or my storage controller is not available for whatever reason, we automatically fail over, and primary storage functionality is assumed by that controller sitting in 1B pointing to the same data. So now what we've done is we've given you fault tolerance for your storage controller on top of a system that's already fault tolerant in and of itself within Amazon. So we're eliminating the single point of failure scenarios. We're giving you the option to replicate data should you need to. We're giving you the option to maintain automatic failover if that warrants or is warranted within your business case. So again, just wanted to let you guys know that we do have this white paper that simply talks about how to create those mounts to those NFS exports and launch your Docker container on top of SoftNAS. Definitely make use of that PDF that's available. As it relates to SoftNAS, you know, we can definitely go into more details, discuss additional use cases, etc. behind the scenes. Definitely reach out and let us know. I'd like to go ahead and shift back now to our presentation. If you have any questions, feel free to submit them via the Q&A panel as well. So I'm just switching back over to PowerPoint, and we're going to talk about some of the storage challenges in public cloud. And what we're really going to do is we're going to divide this into a couple different sections here. We're going to talk about persistent storage, we're going to talk about container security at a high level, we're going to talk about support, and we're going to talk about the lack of expertise and how it impacts DevOps in this particular case. So as it relates to persistent storage challenges, you know, we've kind of talked about this throughout this, or at least at a high level mentioned this throughout this conversation. And there are some challenges when we maintain or have a dedicated data layer within our VMs. And the challenges start making themselves apparent within the networking layer, within the security that's applied to that, etc. And what we want to do is we want to start, I like to use the word abstraction a lot, we want to start abstracting those people that only want to consume storage from the process and the heavy lifting of managing and creating that data layer by using SoftNAS. So our goal here is to allow you to create this data layer very easily, very efficiently, without having much experience in abstracting from most of the manual process that's normally associated with this. And most importantly, I just wanted to bring up and harp on this again, that we can share snapshots of our data to S3 from EBS. One of the things I neglected to mention during the demo is that the replication does not have to be to the same type of storage. So if you have a very high performance system that's currently running your containers in production, but you'd like to place the data from those containers on another type of system, object storage for example, for whatever reason, archival, or when the container is done, maybe it's for purposes of reporting metric, whatever it might be, analytics, etc., we do allow you to share those snapshots to different types of storage after that container is exited, or even while that container is in production, depending upon how we configure and leverage SoftNAS. We also have those container security challenges that they're kind of ever persistent. So if we ever have someone take control of a container, they can essentially use those privileges to go outside of the container and take control of the underlying machine. We still have those challenges. SoftNAS isn't going to remove that problem, but what we're going to do is we're going to give you the ability to manage, at least from that data layer, those exports in a much more friendly fashion. So within the exports tab within SoftNAS, some of the things I couldn't go over because of time purposes was the ability of how we can manage the IDs associated with those users or devices that are connecting to these containers or these NFS exports. We can control via network, we can control via IP list, we can use Kerberos if we choose for an access and authentication and authorization. So a lot of different ways to help you manage that security, at least on a data layer. Now, one thing we also recommend as you're going along and you're starting to leverage Docker more heavily and you're going through and you're creating your DevOps policies, or hopefully if you've already got them in place, you've already done this, but you evaluate your support options in SLA. Because there are uptime challenges. If you look deeply into any of the different cloud providers, there are always these caveats about downtime. Sometimes those downtimes are associated with 12 nines and they're incredibly rare. Sometimes they're not. But one of the things we can do is at that data level, or at that data layer, is we can use a product like SoftNAS that when configured or architected correctly to go along with this solution provides a 5.9 guaranteed uptime. And that is something that we provide in writing, and that is something that's very real and we can leverage as a component of this process. One way, or one good way to augment any processes or procedures or policies you have in place with regards to support in SLA, is to give SoftNAS a call and evaluate our support offerings, our support options, as well as investigate that 5.9 uptime guarantee. So as far as resources and expertise challenges are concerned, storage is definitely a science that a lot of people aren't really interested in. They definitely know they need it, but there aren't necessarily a lot of people out there who can go down to the bits and bytes level of it, and they can manage it at every different facet of a solution, from provisioning that first bucket within Amazon S3 to lighting up that highly available solution can be quite daunting when done by hand or configured by hand. So what we're doing is we're assuming that even if you have those abilities, your time's probably better spent elsewhere. So we'd like to make something much more tenable, much more easy to use, just in case you don't have those type of resources. So our goal throughout that demo was to provide a system that was friendly enough that someone with generalized IT experience could, understanding the business case, very quickly and efficiently and effectively stand up that data layer that you're going to leverage for that particular DevOps process, those Docker containers, etc. And everything that you can do within that GUI that we showed and screenshot right here can also be automated via at-rest API as well as command line. We have guides for both of those, so if you're ever interested in evaluating those, we definitely recommend that you take a look at those as well. So I'll go ahead and hand this over to Taryn for another poll.
All right, thanks, Joey. All right, so our next question is, what is your biggest challenge with Docker storage? Based on some of the challenges that we just showed you, are you having issues with persistent storage, container security, or is it more along the lines of support and uptime, or do you just have, or is there just a lack of resources and expertise? And then finally, are you just not using Docker in your company? So I'm going to go ahead and just give that a few more seconds to be answered, and then we'll launch, and then we'll close the poll. Going to give that about 10 more seconds. Okay, and I'm going to go ahead and close the poll. So looking at our results here, it looks like about half of you aren't even using Docker at all, which is interesting because it means y'all are definitely interested in learning more about Docker through this webinar. We hope we're meeting that goal. And then it also looks like a quarter of you are having persistent storage issues with Docker. And the great thing about SoftNAS is we do tackle that problem directly. Then it also looks like some of you are having issues with container security and a lack of resources and expertise. So regarding the lack of resources and expertise, if you have any questions about Docker, or if you need any help, please feel free to reach out to us and we'll be happy to help you in any way that we can. And with that, I'm going to go ahead and hand it over back to Joey so you can continue with the presentation. All you, Joey.
All right, thank you, Duran. I appreciate everyone participating in that last poll, because that's going to frame up this last portion of the conversation, where we go in and we start talking about SoftNAS more generally. So the focus right now, or up to this point, is really about how we can at least at a high level, start fitting into the process of creating and managing that data layer into DevOps, and more specifically creating persistent shared storage for Docker. But as it relates to SoftNAS in general, everything we've talked about is not specific to Docker. Meaning it's portable across any use case that you can imagine that requires storage in any way, shape, or form. Whether that's storage, to be architected for an application to process 20,000 files any given minute, so they can be handed off to your web methods ERP in a different geography, or whatever that might be. Now, whether your application or that parser is developed in Docker, that's something you can work towards. But the benefits for Docker aren't necessarily specific to Docker. These benefits kind of are far-reaching. So if you have a need for file sharing or those advanced features of the NAS that we've talked about, so if you have the need for CIFS, AFP, NFS, or iSCSI, or if you need compression, deduplication, snapshotting, replication, definitely consider this. As far as managing the data for the containers as it relates to Docker, we want that to be a no-brainer. So we want that to be just as simple a process as you would create any other export from any other machine. Create the export, to define who can access that export, whether it's via UID, whether it's via IP, etc., and then let SoftNAS do the rest, and we can report on the health and availability, etc. So moving on from that, last thing I just want to hit is definitely that the last item on this list, the no downtime guarantee, that 5 nines uptime. That's a benefit applied to everyone once the system's architected correctly. So provided you're moving forward with an architecture that's blessed by the SoftNAS team, that 5 9 uptime guarantee does apply to you, whether you're using Docker, whether you're using it as a simple repository for home drives in your Active Directory system, or whether you're using this to, operate your SQL servers on. A lot of different ways to use this solution. So talking about this architecture again being flexible and adaptable, we're not going to tie you into any one cloud provider. This solution was developed on Amazon for Amazon, so we're definitely an Amazon-centric solution, but we are, as of next month, going to have feature parity As far as the SoftNAS solution is concerned in Microsoft Azure, that means we'll support their Microsoft Blob object storage infrastructure, and all the features we just talked about during the demo will be available within Azure. Again, we have that API guide and that CLI guide. We can provide you a link to those. They work very well inside your CF scripts, etc. If you want to automate some of these builds for creating these data layers, something that we can very easily do. Now, as far as the different types of LUNs, again, NFS and CIFS are the primary use case, with NFS quite possibly being the #1 use case. AFP is there should you need it. If you have those Mac users out there and you need to provide that solution, we're there. iSCSI is also a heavily utilized feature of this platform. If you need to create that block level device to provide, either that symlink to that Linux machine or that disk access to that machine, and have that link be backed by object storage or by EBS or something that's a little more abstracted than just attaching it to the EC2 instance itself, i.e. making it shared, that's something we can definitely do. And as far as the services we bring to bear to make value on top of the simple cloud NAS solution, we do block level replication, inline deduplication, and compression. We do see some very big benefits on both of those depending upon the type of data you pass through it. And that's a conversation we can definitely have in the future should any of you have questions around deduplication or compression and whether or not it's something you can leverage. Almost any type of cloud disk you can imagine we do support. We are looking towards adding additional options for things like Glacier in the future. The multi-level caching is also something to be investigated. Should you need to get additional functionality or, additional throughput and performance out of your storage pools, we can leverage some of those locally attached high-speed SSD drives, whether be they ephemeral, those drives that come along with the instances like your M3s and your C3 type instances, or the preferred IOPS drives that you attach. So we also do writable snap clones. I like talking about those snapshots and those snap clones because they are very powerful. The ability to very quickly, near instantaneously, stand up a volume that contains data from a specific point in time can be infinitely valuable with regards to your DevOps processes, with regards to storage in general for any use case that you can imagine. So definitely let us know if that's something that we can continue to have a conversation on and help you better understand or even pilot or proof of concept within your organization. And the way this really works on the back end, we're in Amazon, we're going to have an AMI. There's two ways to access and consume our AMI. You can either install directly from the marketplace. That marketplace AMI just assumes that Amazon's going to charge you for SoftNAS. The other option has you installing an AMI from the community AMI section. By installing and using SoftNAS BYOL, you can stand up a demo just like the one I showed you that allows you to play around with all the features and functionality up to 100 gigabytes. Once you set that up, you provide data or disk to storage pools. So we'll create those EBS and S3 disk through the wizard. We'll build those volumes on top of those pools, and then we'll have the ability to do block level replication to a secondary storage option if you choose. So again, this technology is portable across several different solutions, several different providers. So everything we've talked about is available on premises as well as in the cloud, which means we support both entirely on-prem and entirely on cloud and hybrids thereof. That does include cloud-to-cloud as far as replication is concerned as well. High availability is subject to some networking requirements that doesn't allow us to go quite as broad as separating geographies, but high availability is available within the individual regions separated by availability zone. but as far as replication is concerned and the communication between these SoftNAS controllers, we can get very creative depending upon what your needs are, whether those needs are Docker, whether it's cloud onboarding, migrating that information that you currently have in place on premises to the cloud so you can conduct that eventual changeover, or whether it's a combination thereof for any use case you can think of. So again, definitely let us know. We'd love to talk to you about what you're doing with Docker, DevOps, or storage in general. So if you have anything you'd like to discuss, definitely reach out and let us know. We do have a lot of technology partners that we're working with, so all the big cloud providers you'll see on this list. You'll also see NetApp. We work quite closely with those guys, and we even provide NAS functionality for their storage grid solution. So a lot of interesting partners that we have out there, a lot of symbiosis that you might not necessarily see or think about when you're just arbitrarily thinking about a generic storage layer. So we're currently in place across almost every segment you can imagine, across almost every vertical you can imagine, using use cases that are so varied it would blow your mind. So again, let us know. We've got several use cases posted on the website. If you go to softnas.com, you can sort by your particular use case, your particular industry, see what's already out there, what we've already developed white papers on, or how people are specifically using something that's related to what you do. And at this point, I guess we'll go ahead and talk about how to get your $100 AWS credit, and I'll involve Taryn here if he'd like to jump in as well. But here is your link.
Thanks, Joey. I'm going to go ahead and take over the screen sharing.
Great. Thank you, everyone.
All right. So, as we mentioned at the beginning of the demo, at the beginning of the webinar, we do offer a $100 AWS credit for those to thank you for joining this webinar. If you just go ahead and click on the link here in the presentation, I've also pasted it in the chat window. You can go ahead and fill out a registration form to get your AWS credit. And then once you fill out that form, one of our team members will email you with the credit information. And then as far as next steps go, you're welcome to learn more about SoftNAS on AWS through the AWS Marketplace by clicking on the first link here, which says Learn More. At the same time, we also have a white paper available that covers the SoftNAS architecture on AWS. And for those of you who asked during the webinar about getting the link to the SoftNAS Docker white paper, that link is available here as well, and it's also been pasted in the chat window. And then finally, if you have any questions for us about this webinar, or you just want more information about SoftNAS in general, please please contact us at softnas.com/contact. And as promised, we've left a few minutes for questions to be answered during the webinar. So I'm just going to go ahead and pull up the list of questions. I'll let Joey answer them as needed. So the first question we have here is, can we use S3 storage for backup purposes from an on-premises infrastructure, or is it better to use EBS?
So this is actually one of those questions that you as the customer would have to answer us. And what I mean by that is object storage or block storage are definitely capable of handling your backups. How frequently you plan on accessing those backups and what your expectations are for how fast you can recover from those backups would pretty much dictate whether or not we have to use EBS over object storage, for example.
Thanks, Joey. The next question we have is it easy to expand volumes without affecting data?
Definitely. So within our storage pool console, we have the ability to simply right-click on any pool that we've previously created, expand that pool, and we simply add any disk that currently haven't been provisioned to a pool. So for a brand new expansion, we would first go to disk devices, add that new bucket or add that new EBS disk, and then we would expand that pool. and it does it completely and seamlessly without bringing down the pool. So you can do that while in production.
Great. Thanks, Joey. And then next question is it easy to add NFS mounts to EC2 container service?
So as far as creating the NFS exports, it's very easy. As far as adding the NFS mounts are concerned, it's just a matter of determining how you're going to build your container service. So usually it's just a matter of referencing the mount somewhere, whether that's part of CloudFormation, whether that's part of your app code, whatever it might be. So yes, the answer is easy. We just need to better understand how you plan on implementing or leveraging that service.
Fantastic. Thank you, Joey. And then last question here is, what encryption methods are supported?
So we support pass-through of any encryption that your disk provider offers. So whatever that might be. At the pool level, we also offer what's called LUKS encryption. LUKS encryption is only available for our block level pools, meaning it's only going to be supported on EBS devices inside of Amazon. It is AES 256. I have some additional information on that that's leaving me right now, but if you need additional information over and above that high level, definitely reach out and I can give you as much information as you like on or about LUKS. We're even evaluating and our plans are currently to allow us to use KMS for managing of encryption keys in the product later on this year.
Great. Thank you, Joey. And then before we end the webinar, we'd just like to remind everyone that this webinar was being recorded and the slides will be available later today. So please keep an eye out in your email boxes for an email from us giving you the YouTube link to this webinar recording along with the link to SlideShare where the slides will be. Also, after this webinar ends, we do have a quick survey available. Please fill out that survey with your honest feedback, whether it's positive or negative, because it gives us a better idea of webinars that we plan for the future. So please fill out the webinar once you're done, and then we are all set to go. We'd like to thank everyone for joining today's webinar, and we hope you have a great day.
Thanks, everyone.
Thanks, Joey.